Let's see if we connect. Are we streaming? Cool, we are live. That means that this time it should work. I actually did this before, and so I don't spend too much time talking. I'm actually going to set a timer on my phone. This is more for me than you. I'll probably go over the hour, but I'm going to try to go through this as fast as I can. I've got my little window here, which this is allowing me to compile because I like to compile through my terminal. I'm using VS Code. I will tell you that I am using Copilot, but I will not be using Copilot to do my logic. I only like using Copilot to do the auto completion because that actually helps speed things up a tremendous amount. I created this before and I thought it would be great to do a walkthrough showing how to do this. I was able to do it relatively quickly, so I'm going to try to do this in only a couple videos. I don't think I'll be able to do it in a single hour. I'll be surprised if we can do it in 3. But I'm going to try to keep at least the majority of this in an hour. I'm going to run through it really quick. I'm not going to explain all the details. If you have questions, feel free to drop it in the comment. There's a great coding community online. There's a lot of support on Discord. There's tons of tutorials out there. I am going to start the nerdy background music. And you'll probably hear this a little bit, but my mic should be over this. The volume should be sufficient. But you should be able to hear this in the movie as well. So obviously a little bit of the nerdy synthy programming stuff. And only reason I'm doing this here is because I'm going to make a new folder. We're gonna move this up a level, and then ls cd pathfinder clear. And just so you guys know, I am using Windows as if I'm on Linux, but that's personal problems. I did this earlier, so I had a practice run. I deleted everything, so we're starting from scratch. So we're gonna open the new folder. We're gonna go to pathfinding. Nope. We're going to go to Pathfinder. That's the new one. And this is where we're just gonna start with our main RS. I know I want to import PyGame. I know I want to import PyGame GUI, which we're not going to use a whole lot. But I used it initially, and I want to add a button at the end of this. So I'm going to implement that. We want to import random. So I know I need 2 to-dos. To-do, because I had some problems before. So if an endpoint is in an unreachable, I just made this a Rust file format. If an endpoint is in an unreachable area, remove the point, collapse the area, and find a new endpoint. And then another to do is, what was the other one? Oh, create a list of possible spawn combinations. So I want to actually spawn the start and end location in different points. And just to give you guys a sample, I'll go ahead and move this over here just so you guys can see what we're building. So this is a sample of what we're going to build. This is the rough draft, and there's some improvements that could be made. This is obviously a very large grid. I think this is a 300 by 100 grid. We're not doing standard BFS because we want to be able to reuse this grid. So this is the end result, or a sample of the end result, but we're going to do everything from scratch as if we haven't done this before. Although I will be referencing my existing code on the side just for design reference, because anyone who programs knows that we don't remember everything. We do have to look things up, and to keep from having to look things up continually, I've already done the work once, so if I forget something, I will reference my other code. But this will be different because there's a lot of things that I learned from the other one. But anyway, now I'm rambling, so we're gonna go ahead and move on. Let me move this back out of the way. Interesting that it's a duplicate. Anyway, so I don't remember what all we're gonna need right now. And I'm trying not to use the reference or use Copilot any more than I have to. But just, I'm gonna just go and do things the way that I always do them. So the first thing I would do is just say hello world, and then if name equals main, you're gonna do that, and then so cd pathfinder clear, we should be able to run Python main, and we get a hello world, and that is what we want. So some of the things, so in my other code, I defined globals, but we're gonna make this local constants. I have a large screen, so if you're following along, you might want to do things a little bit differently. But my screen width is going to be 1800, and screen height is going to be 1100, just because that's how I feel like doing it. Center screen, actually what I'm gonna do, screen size, yeah, we'll say screen size. I don't like saying screen because there's a difference between a surface and a screen. But the screen center is going to be that, but I want to subdivide both of those. I want those to be ints, so we'll use this divide sign. And what we're gonna do is we're gonna say map size is, we'll start with 100 by 100, and we'll say our square size is going to be 40. And this is all relative size. It kind of doesn't matter. When you zoom out, it doesn't matter. Let's see. So actually, this is the number of map squares. So the map size will actually be number of map squares. And I think well, forget. It's not the same. I really love the JavaScript syntax where you can just index into something and say X, but it has to be a member of a type for you to be able to do that. So we'll just leave it like this. The other something else we will need is the number of squares. Number of screen squares will be the screen size divided by the screen square size. But something that we want to do is we want to do we need math.ceiling? I think math.ceiling. So that's something else we need to import math. This is a list of possible spawn locations. That's simple enough. I'm just gonna put both of those there for now. The reason we're doing this is because if you end up with 20.5 squares, you want to draw 21. So you don't want to short yourself a square. We will implement this later. To do only draw squares within the screen size based on camera position. So I'm going to create the idea, if I can remember this, I didn't do this before, but a map inherits a pathfinder, and a camera inherits a map, and a UI inherits a camera, and a game inherits a UI. I think I'm going to try to do nested classes like this. And I don't know if this is gonna work, but we'll try it. So what we're gonna do is we're gonna do a map.py. I keep wanting to write Rust code. Camera.py. A square.py. Oops. A UI.py. Did I forget one? Map, camera, square. Oh, and we're gonna want a color.py. Color will be easy. I can go ahead and do that. From enum, import enum, and then we're gonna do class, color, enumeration, and then, yeah, we're actually not gonna use these. I don't want to do it like this. So we're gonna do black, and then these are going to be tuples. I don't want black to be completely black, so we're gonna do like 88, 88, 88. We'll do gray. White. I don't want white to be completely white, so we're gonna do 222-ish. We will do green. I don't want green to be completely green. We'll do like 185. 34, and I want it on a little on the blue side, so we'll do like 67. We want a red, but we don't want it completely red, so we'll do the same colors, but we'll do the other way. 67 and 34. That seems like a good mix. And then we need a brown, and I know I went through this before, so we'll do something like kind of dark. Like 68, 34, and I don't think that would be brown. I think it'd be like 26, maybe. I think that's the only colors we need prefab. I think we could drop this down a little bit. So this is just our notes. We don't really need that. Colors should be okay. I never started my time, I don't think. I don't know how long I've been streaming. I guess I could look online, but that would take more time. I'm just gonna start my hour right now. We've already done quite a bit. Oh, I guess I could look at the song and see how long it's been playing. 12 minutes, so we're gonna be over an hour, maybe an hour and 15. That'll be okay. So for our main function, I know that we're going to want to, I'm gonna put the game class here. The game is going to inherit the map. So we're gonna we're gonna build a very large nest. One thing I do like about VS Code, I'm a Vim user, I'm not gonna lie, totally gonna nerd out here, but one thing I like about VS Code is that it'll tell you where these are unused or if they are used. We can actually move this to do into here. An endpoint is unreachable. Remove this point. This is going to go in. I knew I was missing one. Path.py. So we're going to need Pathfinder. Oh, and I totally did this wrong. This is not map. It's going to be the UI. There's a reason I'm doing it like this also, so just work with me on this. And hopefully it'll make sense by the end. But from UI, we're gonna import UI. Create a list of spawn locations, so that's gonna be in the map. But let's start at the path. So we're gonna say class Pathfinder. And we're gonna define init, and then we're not gonna follow you. I told you I'm not gonna use you for my logic. Self dot start. I know we're gonna need a start. We'll come back to that. I was gonna try to do like proper typing. Hello nested self. Okay. The goal is to print this from inside the main function. So that will tell us if all of our instantiation is working. So from path import Pathfinder, and then class map should inherit Pathfinder, and then define init self super. So this is going to instantiate the parent class, and then we might not want to do this, but the camera needs to inherit into the UI. The UI needs to be top level, because the UI has to render the screen. The screen has to inherit the camera so that it can create the perspective. The perspective has to be passed into the map. So does the map inherit the camera? There's a little bit of like cross, it kind of goes both ways. We don't want to pass a Pathfinder to the camera because that just doesn't make sense. So what we're going to do, UI camera, so the camera is going to inherit the map because that's how we're going to see things. So from map import map class camera inherits map. And this might not work. This might be a bad idea. But we'll see. We're just gonna go with it. We'll see what happens. So camera goes to the UI. The UI from camera imports camera. And then from class UI inherits camera. So now it's starting to figure out what I want. Let's see if it'll define init. There we go. Sometimes auto-completion is really nice. I've noticed that Copilot works really well with Rust, but kind of like chokes a little bit with Python for some reason. So here we're calling UI. We're gonna instantiate the UI class from inside a game. UI's gonna call camera. Camera's gonna call map. Map's gonna call Pathfinder. And then from inside of the Pathfinder, we should be able to call hello nested. And that should be passed all the way up to the game class. So if we say game equals game, which is not actually a game, but we should be able to say hello nested. And if we run that, hello nested. There we go. So we can, this way, the reason I'm doing this is because the Pathfinder has to be able to have access to the number of map squares and the map size. And so either I end up copying this data all the way down the chain for every layer, or I instantiate them in a way that from the bottom up, every parent layer can access the required variables from the layer below. And so that's the idea, is that the Pathfinder is ultimately the one doing all of the pathfinding, and then that needs to be basically a trait of the map. The map needs to be accessed by the camera needs to be accessed by the UI, and the UI needs to be accessed in the parent game class. And so that's the logic. We will see if this works. I've already spent 10 minutes implementing nothing. So let's dig into the main function. So the number of screen squares, the center of the screen, this is important for offsetting. Screen size gives us the window. The map size gives us the, we'll see that at the bottom level. The number of map squares is important for having the correct number of map squares. So the only thing that we are missing, this is the map width and height. What else do we have? So we have the square size, we have the number of squares, we have the map size, we have the screen size, we have the center location, we have the number of squares. I think that's it. So then all we need to do is initialize PyGame. So we'll do PyGame.init. We will do the UI will actually get the manager, so we'll just leave that here. Actually don't need PyGame here. PyGame GUI, we need that in the UI. So map, I'm kind of a little out of order here. Game UI. This is one reason Microsoft Visual Studio is kind of cool. Lets you pin them down. Should probably do that with this, but yeah. Whoa. What did I do? Guess I've done it. Map, main, UI, camera, map, path, and then square. Okay. Let me pin them. I have to do it the other way. So main, UI, camera, map, and square. Cool. And since we haven't done it, we'll go ahead and just implement the class square, and then not that kind of square, buddy. Define init self location. I wonder if the square needs to inherit the Pathfinder, if the Pathfinder needs to inherit the square class. That's kind of interesting. We need an array of squares, so I don't think there's a way to share that data in a uniform way, since we need a large number of instances of square unless the square inherited a single trait. And I'm not going to go that far down the rabbit hole. We'll just say location, size, color, outline. That should be sufficient for now. Go ahead and give me all them. Sure, thanks. We're just going to change this one to X. And 0. Self location 1. And the thing I do remember is that every square needs access to the screen. import PyGame. We can actually say from PyGame import draw. Define a render draw function. I do know that we're going to do some magic here. When we call this draw function, we're going to want to include the camera props. So we're gonna have zoom be camera props 1, and then we're going to unpack the origin X, origin Y from the second. So we'll pass that in as a tuple of tuple, and that's a tuple. I'm not gonna factor in all of the logic yet, but X is going to equal self X. Y is going to equal self dot Y. Color, I already know, so I've encountered this before. With the color class enum, when we call this value, we're getting an instance of this dictionary. So this tuple is actually nested in a dot value. So if we want to pass in a raw color, we're going to need to create a little utility function called getColor, or actually setColor, since this is actually a setter. Self, since we have to have self unless we do a what's the word? It is called a static method. In that case, we don't need self. But actually we do need self still, so let's forget that. So we have to set the color. So it's always going to just be here. What we'll do is we'll actually get rid of this property altogether, and then we'll just say self.set color, and then what we'll do is we will say that if color is an instance of a tuple, then we will just set the color. Otherwise, we actually want the color value. So that way we can pass in color as an enum here. So we have a what was the word? I just drew a blank. A union of either a tuple or a color type, but I don't want to import color, so I'm not gonna just include that here, but that's what that would be. But I'm not gonna do type safe Python because that's kind of stupid in my opinion. But we can check those colors in a minute. So this is majority of our square class, but let's just keep going. So we're gonna say, I want to say size equals size, self.size. We're not gonna use zoom or origin yet. And then outline can just stay the same. I'm not gonna change anything about that. This way we can call the color. Actually, we don't think we're gonna modify the colors. So that one can go away. I know we will translate X and Y, and we will modify size. Screen only gets passed in once, so that stays there. Outline's fine. So all we have to do now is modify this function when we want to plug these in. And for now, we can actually initialize these as nothing, so that way this function doesn't fail if we don't pass this in. We can fix this later. To do delete initialization. props. Okay, we could theoretically close square, but we'll come back to it. We're not going to deal with Pathfinder until the very end. Map, we will start implementing square here soon. So from square, import square. I know we will need self.squares here. And actually I lied. We will implement this on Pathfinder, and this is the whole reason for the nesting. So Pathfinder will actually probably handle the initialization of most of the map traits even. But we could handle the initialization in map now that this is here. And that's probably what we will do. We'll try to keep the Pathfinder functions strictly to finding the path. But now we have this flexibility with our super, which is super because we can calculate all of these render functions at a higher level as well. I know at a camera we're gonna actually also want a mouse class. It's not going to inherit anything. And all we want for the mouse is self.previous. Yeah, let's do previous position. And then we'll even do update position. And that should be sufficient. And then we can say self.mouse equals mouse. So we're still doing a lot of foundational framework. It's kind of a good bit of work before we get anything usable, but I've done this once before, so just trust me, I know that we're going to need this stuff. UI is going to be pretty empty until we implement the GUI. We're not going to do that until we need it. So let's get on to our main render loop or main game loop. So we are going to implement a trait or a member or parameter called running. We're going to initialize that to true, and then we're going to say that while let me put this up here. Oops, I forgot to finish initializing PyGame. But anyway, while game.running, and we will handle our events. I don't need hello nested anymore. I don't know what. Alright, so this is the kind of stuff that people don't usually remember all of this unless you do a lot of work in PyGame. So we're gonna say while we're running, we're gonna say for event in PyGame dot event dot get. Surprised that yeah, there we go. We can. We're not gonna do. Actually, that's not the worst logic. We will leave this. We might do this. I'm not actually completely against that. I do want to do this. I want to say that if we have a quit event or we push down the escape key, then we're gonna set running to false. And so this is where we actually will say, we'll have a update function, and we will just have it print updating, just to make sure that our logic is working. Some of the things that I forgot, we need to go back and initialize those. Now we're gonna set the, will it finish for me? The set caption, Pathfinder visualizer, I like that name. And we will set the screen to screen size. We will set the clock to clock. And then with the clock, we can, I guess I don't have to look it up, but what we're gonna do is say clock.tick. And then we're just gonna say 1 second for now. And I always forget, but we'll have to come back and change that because we'll have problems later if we don't. So this is 1 tick per second. So a lot of people do something other than PyGame.update the display, but I prefer that way, and no real reason why. I just like doing that. But what we're gonna do is we're gonna fill the screen with our color black, and we're gonna have to call the value. And so we will import color from color, import color, and we can use this to test our colors. But I would create a little loop for every tick to change the color, if that wouldn't probably mess some people up. But the other thing that we want to do is check and make sure that our game function is updating. So we should see that here. And what we'll do is we'll just see if we have any errors. Error attribute black, and enum, oh, because it's all caps and it's not. So here is our gray screen, and every second we are getting an update. So cool. We've got about 40 minutes left before my timer goes off. So this is our black. Let me see if we can make it just a little more black. That's not very black. Let's cut that in half. And this is a lot closer to black, so that works. It's almost the same color as my background. Let's test this with let's check our brown color. So there's our brown. It's a little red. Probably pull back on the red a little on that. Let's try 48. Yeah, so that's a nice brown color. Let's go ahead and check our green. I'm hoping our green and our red are kind of bright. Yeah, okay, because I want these to stand out on the map. And then we will try red. And our red is very orangish, kind of ugly, and almost hurts my eyes, but that'll work. I'm fine with that. We could probably swap the blue and red values, and that would give us a bit more of a purplish color. That's sufficient. It's almost the pink neonish color, but that works. And then white and gray, I don't really have to test those. So what we're going to do next is initialize our map. So I know this is a little different than how I did it before. One thing I know that we're gonna want something I didn't think about is these update functions are going to be passed all the way down. That's going to be interesting. So we can't name... we don't want to name them all the same thing. Or if we do, we want to explicitly name them things that are going to not overlap. It's going to be fun. Okay, so we can get rid of our update function for now, because I don't know what level that update function is going to be on. I imagine it's going to be on the UI level. But the first thing we want to do is we have a list of squares. Wow, this is actually kind of hurting my a little bit. So we want to self.create map, and our create map function. Let's think about what we want to do. So the first thing we want to do is populate the list of map squares with blank squares. The second thing we want to do is generate noise and convert squares to mountains. So water would be interesting too. I didn't think about that. Do we want to implement water? That would be quite interesting. Heck it, why not? Okay, populate list of map with blank squares. Then we're going to generate the noise and convert squares to mountains or water. Then we want to generate spawn and endpoints. So let's focus on that now. Okay, so when we implement this check, I want to extrapolate that out to here. Damn it. I can't type. To do extrapolate endpoint quality check to reach spawn. On creation, I want to check that the endpoint is a valid endpoint when we create it. Although that creates a bit of redundancy. Can we? We might not be able to. So the first thing we want to do is populate a list of map squares with the black squares. So on the path level, we need to get the number of map squares x equals, and this is where we have to start passing stuff down. Map squares, we're just gonna pass it in like that. Map square 0, and then the 1, and we will pass it to map, and we will pass that to super, and we will do this on the camera. I'll pass that down there. We'll do this on the UI. We'll pass that there. The reason we're doing this too is because it makes it available to all of the parent classes, which is the goal. So here we have to pass it down here. And we can actually add the type check here. Say that this is a tuple int. So the map squares is simply just the number of map squares. And it actually still just says any. That's interesting. So I guess this is kind of just gobbledygook. Or actually, I wonder if that was a typo. Now what does it say? Still just any. Okay. Well, then this is kind of stupid here. We'd have to probably start at the bottom level. Let's try that, just out of curiosity, since we're just messing around anyway. Pass it in here. Does it have that requirement? Nope. It would have to be all the way up, and I'm not doing that. I've been debating on type-safe languages and unsafe weakly typed languages, and it just seems like a silly idea to me. But anyway, so squares are here, so we want to say define populate blank, or we will just say init map. How about that? Self. This one will also call self, and then here we will say for x in self dot number of map squares x. For y, I'm gonna append the square. And then here we can just call self init map. But this is not what our square looks like. I don't think, anyway. So the first thing we have to do is pass the screen in. So on this level, we will need the screen. So we'll take screen. Screen. What am I doing? Needs to be uniform. Screen. Screen. This is a bit more of a roundabout way of doing this, but it'll pay off later. I'm specifically calling these a screen because we're drawing to the screen, but I'm gonna specifically call it a surface here because it is a surface. And I know that's a bit backwards, but what are you gonna do about it? So we're gonna pass the initial, where are we at? We're gonna make a square, we're gonna pass it the screen. And this becomes a reference of the screen. So self.screen. Locations equals XY. Size is going to be, we're gonna have to pass in the square size, but let's just cheat. We know it's gonna be 40. We're not gonna pass in a string. We're not doing string parsing. We're gonna from color import color. We're gonna say color dot gray. We're gonna make them all gray. Our square should parse this into a color value, even though we could explicitly just call it a gray dot value here, and you can see by doing that we end up with the tuple of 3 literal values, but here we get the literal enum class. So we do want it to be outlined, and I think that's all we need at this moment. Screen, location, size, color, outline. And then for our zoom and origin, we'll pass this in when we draw. So it kind of sucks that we have to pass it to every square. Kind of sucks that we have to pass all of this to every square, but unless we... I just don't even want to go down that rabbit hole. Let's not. We're running on time. I got 23 minutes, so let's see if we can get our basic camera and top level UI up and running. So this should give us all the squares. All the squares should be there. They should be on the screen. The only thing that we're missing is actually these need to be multiplied by the size for this location to work. So map needs to have a draw function. So this function will actually take in the camera and pass it to the squares, or the camera properties. So the camera needs to have a render function, and then we will call the draw function, and then the UI will have an update function that calls, we're not going to update, we're not implementing the manager yet, so I don't really care for the logic, but we will call self.render. And then here we can now skip the game level and we can use game as a top level access to game.update. And if that worked, which it did not, because int is not iterable, because I let the game do the logic for me. So for x in range of x squares, range y squares, and to be proper, these should actually be the other way around. Should always go down your rows and across your column. So for each column, when we get to the end of the column, we're going to go to the next row. Then I know that we're going to have an index. And this is not right. I also know that we are going to need screen center X and screen center Y. And so to get that, we're gonna need screen size. So we can say screen size 0 divided by 2. I want a whole number. Actually, I don't technically need a whole number. We can be off by a little bit. But to get the index, we're gonna need location 1, which is our Y value, times our screen size 0, which is our X value. So for each row, we're going to multiply it by the number. Oh, this is not screen size. This needs to be the, so we're going to need something else. We're going to need the number of map squares X. A lot of data to pass in. But how about we calculate this at the top level? How about we just pass in an index and we save the logic to the map side. So we already have number of map squares here. So do we have a screen? The map's gonna need a screen width, right? We don't have that passed down yet, so we're gonna get a screen size And then we will say self dot screen width and screen height. And we have the number of map squares. That's passed to the Pathfinder. The Pathfinder does not need to know the screen width. The map technically shouldn't. Be right back. to excuse the mess. And I brought the little guy with me. Whoa. So, you're just gonna have to excuse the mess. And I'm gonna have to try to do this one-handed because he is up and he is ready to rock and roll. Bubba, Bubba. Let's see if we can even do this. What? I'm sorry. Let me try to... This might not work. Yeah, I'm in the process of moving my stuff to the garage. I've got 12 minutes. See if we can get this working. So int is not iterable. I think we fixed that. Let's see what our next error is. Init requiring, oh, because we need number of map squares. Totally lost my train of thought. The square needs the index. So we got the screen, and then we need the screen size. But it's not screen size, is it? Where is it? Yes, it is screen size. So actually, let's just reconstruct this as screen size, and we can pass self.screen size here, and we can pass the y times the number map squares x. Oh snap. Actually, let's just say index. Then we can say index equals. Where you going, little guy? Where you going, Bubba? Just looking. Yep, that's the equation. There's our index. Is this all of the values? So we have index, location, size, color, outline. What are we missing? Init or camera. The camera doesn't have screen size and map squares. Map wants screen size and map squares. So we got screen, don't have screen size. Where you going, Bubby? Screen size, then screen size. Where you going, Bubby? And that should be top down, and then we have our grid of squares. They're gray squares, but we forgot to change the background color back. So while I'm still thinking about this, we're going to go ahead and move the tick size up. We're going to change the background back to black. There we go. Now we've got our grid on our map. Son. My son. Get at it. See my cup? I should have brought his toys out here. What about this little cowboy hat? I've got 10 minutes. Let's see if we can implement a camera. And I'm gonna go back and look at my other one just to kind of cheat a little bit and look at what we need. So I know we're gonna have a move function. And I know we're gonna have a zoom in function, and a zoom out function, and a max zoom function, and a min zoom function. Then for us to be able to do that, we need to have a self camera position. Let's just do it like that. And then we'll have a self.zoom and a self.maxzoom. What about this one? Yeah, no, that one doesn't make any noises, huh? So because we have a mouse, previous mouse, what we're gonna do for the mouse is we're gonna create a find update camera, and we're going to say that the current mouse position is PyGame.get mouse. So we're gonna have to import PyGame again, or we can say from PyGame. And for our move function, we'll pass it a mouse position. And we will call the self.move with the current mouse position. Then we'll self.mouse.update function with the current mouse position. And then in the move function, we will get the distance x is going to be the current mouse position the previous position. Since we're already factoring zoom, we will divide this by zoom, which is currently 1. For dy, we will do the same thing. For new x, so what we're going to do, we're going to calculate the new x as the current camera position, and new y is also the current camera position. Then we are going to scaled center x is going to equal the screen center x. Is this still a variable screen center x? I have to make sure we put that screen size. So we're actually going to have to say screen size 0. Oh, buddy, are you okay? So this will give us the center of the map. We can't look past a scaled. This won't let us go past the edge, essentially. Nice done, you got the hiccup. We got 5 minutes left. Let's see if we can knock this out. So if the scaled center x is less than the new x, and the new x is less than the map width, are we passing in the map width anywhere? map size. So we don't actually pass in the map size. We have the number of map squares. We need to pass in the map size. So then we need to pass in the map size. No, buddy. What about this one? About this control? Is him okay? To pass this down to the UI and to the camera, as far as I know. We can pass this down later if we need to. And then we say self.mapSize 0 minus the scaled center. So what we're doing is we're saying the map size minus the center x, half the map. And then 0 plus half the size. So we don't want the edge of the map to go past half the map. That'll probably make more sense in a minute, but do the same thing for y. And then we should be able to just say self.update camera. Or we could call it on the UI level because render is going to draw, so we can update. We'll update the camera and then we'll render. That makes a little more sense. So init takes 4 positional arguments, 5 given on the camera level. Because camera is not passing map size down to the map. It's odd, but the camera is the only one that needs the map size for now anyway. So we don't have anything getting our input. So really, this should just update automatically. Buddy, are you okay? Alright guys, it's actually dinner time, so I'm gonna have to cut this short. I'm not exactly sure what we're missing, but we'll get this in on the next episode. So made some progress. My timer just went off and my baby wants to eat and I want to eat and I'm tired of being at my computer and I've got to paint this door behind me. So say bye everybody.